Hello and welcome to the NPTEL MOOCs course on Foundation for Virtual and Augmented Reality System. We are currently discussing cybersickness as part of lecture 6. So, we will continue our discussion on cybersickness. So, in the previous part of the lecture, we have talked about partly talked about the causes. So, we covered a few factors that falls under two categories. One is internal, other one is external hardware part. Now, we are going to talk about the remaining category, that is external content part. Also, in this part of the lecture, we will start our discussion on how to evaluate or measure cybersickness. So, let us first quickly have a look and complete our discussion on the remaining part of the causes. So far, we have covered the internal factors, that is age, gender, motion sickness, susceptibility, physical condition and emotional condition. We have also covered partly the external factors. More specifically, we have covered the hardware factors, hardware related factors, namely display resolution, latency jitter, type of display and type of input. Now, we are going to talk about the factors related to the VR content. So, there are 6 such factors: visual motion, means of locomotion, field of view, type of content, duration and visual complexity. So, let us go through each of these in some details. Design of virtual environments can have significant impact on the likelihood of CS, also the severity of CS. One factor which is related to VR content is visual motion. Now, visual motion stimulus, which is the movement experienced by user in a virtual environment, is considered to be one of the primary causes of cybersickness. Higher such visual motion can increase risk of CS, and the way the content moves, that also affect CS. The way the content moves within the virtual environment also affects CS and its severity. Vexation or the sensation of self motion is the highest when we sense motion in peripheral stimuli. So, if there is motion in peripheral stimuli, then our sensation of self motion or vexation is the highest. And it has been found that there is a positive correlation between vexation and visual motion stimulus. So, that positive correlation affects or indicates that visual motion plays a crucial role in the overall onset and severity of cybersickness. In addition, severity of CS also significantly increases with larger height and faster speed in virtual environment. So, the viewpoint during motion also is an important factor. However, counterintuitively, there is finding that brief exposure to turbulent visual motion is alone not enough to induce CS. So, typically we expect that if we are exposed to, in the virtual world we are exposed to turbulent motion roller coaster ride sort of things, then that may lead to cyber sickness. However, brief exposure to such turbulent motions do not induce cyber sickness. Longer exposure certainly can, and that is somewhat counterintuitive finding. CS also increases with the increase in angular velocity and more intense when the rotation is taking place around x and y axis as compared to the z axis. So, that is another finding from the studies. That is about visual motion and cyber sickness. Then another content related factor is means of locomotion, how we are moving in the virtual world. A sensory mismatch can occur when users' virtual movements do not match their physical movements, and this mismatch results in discomfort and disorientation, which in turn leads to cyber sickness. One aspect of locomotion that affects cyber sickness is control over motion. Whether we are controlling the motion, in which manner, that affects cyber sickness. So, that control over motion has a direct effect on presence and an indirect effect on cyber sickness through presence. A greater sense of presence in virtual reality can lead to lower likelihood of experiencing CS in general. Of course, it need not always hold true, but in general greater presence leads to lesser CS, and control over locomotion is related to presence. The more control means greater presence, less control means lower presence. Now, type of control mechanism used in VR as well as the extent of control. So, type of control and extent of control both are important. They determine the likelihood of experiencing CS. For example, hand based motion control leads to significantly less CS as compared to whole body motion control. These are some of the findings in research studies. Another aspect of locomotion that affects CS is type of transition. So, locomotion means moving from one point to another. One is how do I control the movement, other one is how do the scenes change, how the transition takes place from one field of view to another field of view. So, when we are performing teleportation, that is instantaneous transition, that type of transition seems to be less cyber sickness inducing as compared to other means of locomotion. So, teleportation is found to reduce cyber sickness as compared to naturalistic free movement like walking, running, jumping and so on. Field of view is another VR content related factor that affects our cyber sickness susceptibility. What is field of view? That is the extent to which users field of vision captured by the display in a VR headset. Larger FOV means larger field of vision is captured, and larger FOV generally results in greater immersion. Research has found that reducing field of view can be an effective way to alleviate symptoms of cyber sickness. However, excessively narrow field of view can lead to decreased immersion, which in turn lead to increase in head movement to basically look for things in the environment, and that increase in head movement may likely to exacerbate or increase CS. Of course, it is a challenge to find the optimal FOV, but that is very crucial for creating comfortable VR experience. Type of content, another important factor. Action content, fast movements, abrupt alterations in the VR environment are found to be inducing more cyber sickness as compared to neutral and static content. This somewhat is quite obvious. However, users with high preference for adrenaline sports, those who likes to take part in adventurous things and high adrenaline sports, for them exposure to such content may not lead to cyber sickness. They are already accustomed to such behavior, such environment. So, for them exposure to action content, fast movements or abrupt alterations in the virtual environment may not lead to severe CS as compared to those who are not exposed to such type of sports or adventures. Genre of virtual environments also play a significant role. Horror content based on horror scenes are likely to induce more sickness as compared to pleasant genre. Geometry and terrain of VR also affect CS. So, when in a virtual world a user is traveling in the presence of regular bumps and irregular terrain, then so in such scenario CS is likely to happen as compared to when the same travel is taking place with a flat terrain, on a flat terrain without bumpy rides. Weather condition in the virtual environment, the kind of weather condition the user is exposed to can again affect the induction of CS. Higher CS is likely to happen during stormy conditions in the virtual environment as compared to clear weather conditions. So, these are obvious things, quite intuitive, and that happens. It has been found to take place in virtual environments. Duration of exposure related to VR content is another important factor. Several studies highlighted the importance of VR exposure time or duration on cyber sickness. Several studies were conducted. Prolonged exposure was found to be leading to greater CS when the exposure is through HMDs. That is, the users are wearing head mounted displays and for a long duration, then cyber sickness is likely to be more. CS also increases with VR exposure time when users use different locomotive controllers during navigation tasks. So, depending on the locomotion technique adopted to move from one point to another in the virtual environment, we have already seen that affects CS, and that gets further complicated with longer duration. Continuous exposure to live action 180 degree videos results in higher CS. This again increases with exposure time. Visual complexity, another external factor. Studies have shown that visual complexity positively correlated to CS symptoms. So, we can positively correlate CS symptoms with visual complexity. Increase in complexity leads to increase in CS. So, the more complex the scene is, comprising of more objects of different shape, size and different movements, then the CS induction is likely to be more. So, that is about causes. So, earlier we covered internal factors and partly the external factors, namely related to hardware. In this part of the lecture, we have covered factors related to VR content, which contribute to the onset of CS or severity of CS. Now, our next part of the discussion will cover how do I know or how do I measure the extent of cyber sickness, how do I evaluate cyber sickness. Now, measurement techniques can be many, and the techniques rely on three things. One is the input, what input we are providing, inputs for measurement, then the measurement technique itself and what kind of output we are generating. There can be many forms of input, questionnaire based, physiological and biometric information, behavioral information, content based information. Evaluation process again or the measurement techniques can be different. We can have manual evaluation, automated evaluation, machine learning based, and real time evaluation while the experience is taking place. There can be further subcategories also as shown here in this summary. Then output also can be of different nature, it can be binary classes, multiple classes or sickness score, a number. Let us go through each of these categories and subcategories in some details to get a better understanding of the evaluation process. Let us start with the first thing, that is input. What input we assume for measuring cyber sickness. So, there can be different forms of input. One is questionnaire based. This is one of the common ways of taking input to measure cyber sickness. So, these are self-report questionnaires or scales to rate users' discomfort or disorientation on a numerical scale. So, these are generally in the form of ratings. Now, these type of rating scales for measuring CS are quite common. They are easy to administer and help the researchers or practitioners to better understand the causes and identify potential interventions. Typically, these scales are administered before or after the experience. Sometimes they can be administered even during the experience as well. So, before, during, after, all three are possible, but mostly before or after and occasionally during the experience. So, one common scale of measurement used for cybersickness is SSQ, which stands for Simulator Sickness Questionnaire. It is in fact one of the most extensively used questionnaire for the purpose. It contains 16 items or questions divided into 3 subscales: oculomotor subscale, disorientation subscale and nausea subscale. Participants are asked to rate intensity of individual symptoms belonging to these 3 subscales: oculomotor, disorientation and nausea, on a scale of 0 to 3, where higher score denotes more severe symptoms. Now, SSQ was not originally designed for VR, it was designed for some other purpose, but adapted or rather adopted to use in the VR context. But there are other questionnaires that are specifically designed for VR. Say virtual reality sickness questionnaire or VRSQ. Then we have cyber sickness questionnaire, CSQ. This is good for evaluating VR experience with HMDs. The second one. Then we have shorter and more concise questionnaires to assess specific conditions such as misery scale or MIS, fast motion sickness scale or FMS. There are questionnaires for measuring susceptibility to CS like MHQ or motion history questionnaire, MSSQ or motion sickness susceptibility questionnaire, VIMS or visually induced motion sickness susceptibility questionnaire, VIMS-SQ. Also, there are some commonly used questionnaires to assess overall discomfort, namely nausea scale, motion sickness assessment questionnaire or MSAQ. So, there are many such questionnaires that are available which are used to either detect or measure the susceptibility of cyber sickness. Another kind of input that we can consider for measurement apart from these questionnaires is the physiological or biometric input. Now, subjective questionnaires or these questionnaires based input can be subjective and which is prone to inaccuracies. It may not always be reliable. So, to overcome that, we can use physiological inputs or biometric inputs which can be used to detect CS. Such inputs can be heart rate, galvanic skin response, EEG and so on. There are in fact a large number of such inputs which we can use. Let us see what kind of inputs we are talking about here. EEG or electroencephalogram, it is one of the widely used input to detect CS. Then we have electrocardiogram, ECG. Then electrogastrogram, EGG. Electrooculography, EOG, respiration signals, photoplethysmography, PPG and electromyogram or EMG. Also we can make use of galvanic skin response or GSR. So, that is about different sorts of physiological or biometric input. Another kind of input can be behavioral input. It is possible to detect CS using behavioral cues as well, such as blink rate, head and body movement, how we move them, and postural sway. These can have useful features for measuring CS. Axial movements or change in user's center of pressure during VR exposure can be used to monitor postural sway, which is one of the ways to measure CS. Studies have shown positive correlation between postural instability and severity of CS. So, postural sway can be measured using axial movements, and it has been found that postural sway can be an indicator of severity of CS. Content based input can also be taken to measure CS, to evaluate CS. Complexity of visual environment in VR can contribute to CS. We have already seen that earlier as part of the cause. Now, researchers have studied different features related to VR content to evaluate CS. What are those features that stand out for CS measurement? Optical flow, which is apparent motion perceived by VR users due to relative motion between user and the environment. Depth cues, exceptional motion velocity, which can be another key cause of CS. So, these are some of the content based input that can be utilized to measure CS. So, we have covered inputs part, inputs for CS measurement. There are 4 such categories of inputs: questionnaire based, which is subjective, physiological and biometric, objective, then behavioral and content based. Now, let us have a quick look at the evaluation process. What kind of techniques we can use to measure CS based on the input. Now, this measurement techniques can broadly be of 2 types. One is manual evaluation, that is based on human intervention. Other one is machine learning based evaluation or automated evaluation, where automated algorithms are used on the input to measure CS. Typically, assessment conducted by means of questionnaires such as SSQ or VRSQ comes under manual evaluation. It is quite obvious. So, there somebody has to distribute the questionnaire, collect the feedback and go through the responses to come up with a decision on the severity or onset or possibility of cyber sickness. So, that is entirely human intervention to measure, and that comes under manual evaluation. As opposed to that, we can make use of the other inputs, say for example, the physiological or biometric input to train models to automatically determine cyber sickness. So, that comes under, that type of automated approach comes under ML based evaluation. Now, there can be different ways to perform ML based evaluation. One way is through the use of transparent models. So, these type of models provide clear insight into decision making process, and the model's inner working can easily be understood. So, when we are able to do that while performing a automated or machine learning based evaluation process, then we say that we are making use of transparent models. Many studies have reported transparent model based approach to measure sickness from objective or the physiological or biometric based inputs. For example, stepwise regression analysis utilized to measure CS using a variety of physiological signals, physiological inputs. Now, stepwise regression can be considered to be a transparent model. So, we have covered a part of evaluation strategies. In this part of the lecture and the previous part, we have covered the causes, what are the things that led to cybersickness, that lead to cybersickness. Also, in this lecture partly we have covered evaluation. We have seen that there are three aspects of evaluation or measurement: input, what kind of input and how we are getting the input, then the process, how we are processing the input, and third one is output, what we are getting as output. In the input front, we have seen that we can go for subjective questionnaire based rating scales or rating scores as input, or we can go for objective inputs such as physiological signals or biometric signals, or we can take behavioral input or content based input. In the evaluation part, we have seen that we can go for manual evaluation, typically based on the questionnaires or rating scores, or we can go for automated evaluation, typically machine learning models. Now, there we started our discussion with transparent models. These are models that are easy to understand and we know how they work. The remaining part of the evaluation as well as the mitigation strategy we will be covering in the later part of this lecture. So, I hope you have understood the concepts and looking forward to meet you all in the next part of the lecture. Till then, thank you and goodbye. Happy learning.